bucka. Haha. You know the deal.
The next thing we're going to talk about with analytic geometry is graphing the line. And there are a couple of different ways to graph the line. Each of the first couple of ways, though, involve having the equation written in slope y-intercept form. So for the purposes of this video, we're just going to assume that the equation is already in slope y-intercept form, and we've talked about how to get it into that form in the previous videos. So the first way we're going to look at coming up with the graph of this line is by coming up with the ordered pairs. And when we're coming up with ordered pairs, we pick values of x and then solve for y. Usually I recommend 3 or 4. I mean, the minimum that you would need is 2, but if you happen to make a mistake, it's nice to have 3 or 4 points, because when we graph this, it should make a line. So I usually recommend maybe -2, -1, 0, 1, and 2. And we talked about this solving for y and graphing ordered pairs. So again, this is not something I'm going to really go into great detail about. But if you're not really familiar with how to come up with the values for ordered pairs, I suggest you watch the video on graphing ordered pairs. And that's in the grade 9 relations playlist. But essentially what we're doing here is we're substituting in our value for x into the equation and solving for y. So if x is -2, we get 3 times -2, which is -6, plus 2 is -4. So if x is -2, y is -4. Same thing for the next value. X is -1. 3 times -1 is -3, plus 2 is -1. And so on. And as I continue to solve here, if x is 0, y is 2. If x is 1, y is 5. And if x is 2, y is 8. So now if I go ahead and plot those points on my graph, we'll start at -2, -4. So where x is -2 and y is -4 is the point right there. Where x is -1 and y is negative is there. 0, 2, so that's our y-intercept on our y-axis there. 1, 5. And finally, the last one that I solved here was 2, 8. But of course, we could keep going forever. And we can see that the shape that starts to emerge here is a line. And if we were to join these points together, we would see that it does make a line. And it's a line that goes on forever in both directions. So again, I've only graphed a few of the ordered pairs here, and then joined them together with the line. And then when we draw the line, we're showing all of the ordered pairs that we can. I mean, the line does go on forever. It keeps going up. We have infinite values for x and y in both directions. So here's another example of an equation written in slope y-intercept form. And again here, I'm going to use ordered pairs to come up with my graph here, to be able to graph this line. And I need at least 2 to make a line. I would suggest 3 or 4 again. So here you'll notice the slope is a fraction. So if I substitute in just random values for x here, most of the time we're going to end up with a fraction as an answer, and we're going to have to add and subtract here to try to isolate y. So I try to not deal with fractions as much as possible because they're somewhat challenging. So we know that a fraction is essentially a division question, and when we multiply 2 over 5 times x, And that's what I have to do here in order to start to solve this for y. We would take whatever value we have for x and multiply it by 2 over 5. So for example, if x is 0, well, that's not an issue because then the fraction disappears. 2 over 5 times 0 is just 0, and 0 minus 3 is negative 3, which is our y-intercept. So we should recognize just from looking at the equation that one of the coordinates is 0, negative 3. But when we want to come up with other values, I don't want to just choose negative 2, negative 1, and so on here, because if I choose those values, I end up with a fraction that I have to subtract 3 from. So with a fraction, since I'm multiplying times x, 2 times x, and then dividing by 5, what I want to end up with when I multiply by x is something that 5 will divide into evenly. So I want a multiple of 5. In order to guarantee that I get a multiple of 5, we want to choose multiples of 5 for x. So instead of going down to negative 1, I'll go down to negative 5. And then we already know the value for y when x is 0. But I'll also choose positive 5. And if I continue to count in 5s here, positive 10 as well. So let's see the values that we get when we substitute those values of x into the equation. So when we substitute negative 5 for x, what we get is 2 over 5 times negative 5 minus 3. And we're trying to solve for y, so y is still by itself on the left-hand side of the equation, so I just simply substituted in negative 5 for x here. Well, in order to multiply the fractions here, and that's what we have to do first, because we have to follow BEDMAS, we're going to multiply 2 over 5 times negative 5 over 1, which is negative 10 over 5. And then a fraction is division, so we have to do that division before we do the subtraction. Negative 10 divided by 5 is negative 2. And then minus 2 minus 3 is minus 5. So if x is negative 5, y is also negative 5. Now, again, I'm not going to go through each one of these step by step. This is something that was covered in graphing ordered pairs. But when we substitute in 5 into that equation, we get 2 over 5 times 5, and then minus 3. 10 divided by 5 is 2. 2 minus 3 is negative 1. So if x is 5, y is negative 1. And the last one, if x is 10, 2 over 5 times 10 over 1 is 20 over 5. 20 divided by 5 is 4. And 4 minus 3 is 1. So if x is 10, y is 1. So if we plot these points here, we can start with negative 5, negative 5, which would be there. Then we're at 0, negative 3, which is our y-intercept there. And again, we should recognize that that's where the y-intercept is just from looking at the equation. We don't necessarily have to solve the ordered pair there. Then we're at 5, negative 1, which is our coordinate there, and 10, 1. And once again, when you've got your 4 points and they make the shape of a line, there's a pretty good chance that you've done them all correctly. Because now when we join these together, they do make a line. So once again, we've done it. We've graphed the line. Now, because the slope was a fraction, rather than just choosing the usual values that we would choose for x, maybe negative 2, negative 1, 0, 1, and 2, we're choosing multiples of the denominator. And the reason for that is because we want to end up with something that is not a fraction. It's a little bit easier to deal with. Now, this is assuming, of course, that the slope is not a fraction, which it wasn't here. And you know, some of the times you might have cases where you have to just deal with the fractions, and that's just the way it is. But if that y-intercept is not a fraction, but the slope is a fraction, choosing multiples of the denominator makes your life a little bit easier if you have to calculate ordered pairs. And that's one way to graph the line, is to calculate ordered pairs and put those ordered pairs on a graph. and hopefully they make the shape of a line. If they make a shape of a line, then there's a good chance that you've calculated them correctly, as long as it's a linear relation. Another way to graph an equation of a line is to just use the equation. Now, of course, we just did use the equation to come up with ordered pairs. But when I say use the equation, I just mean you look at the equation and you're able to graph the line from the information that's in the equation. And once again, this is assuming that the equation is in slope y-intercept form. It has to be in y equals mx plus b first, so that you can look at the equation and know what the slope is and know what the y-intercept is. So let's look at this one here. Again, we already graphed this line using the ordered pairs. This time we're just going to look at the equation and start with the fact that we know the y-intercept is positive 2. So right away we know one point on the line, 0, positive 2. That's the coordinate of the y-intercept. So in order to draw a line, though, we need at least one other dot, one other point. And I prefer to come up with 3 or 4 other dots to make sure that they do make the shape of a line, just in case I've made a mistake. So in order to come up with the other coordinates, the next thing we're going to do is look at the slope. And here's where we're going to go back to that original equation that we used for slope. If you recall on the video on how to calculate slope, the first equation that we came up with was rise over run. And we haven't really talked about that equation a lot since that video. But this is a case where understanding that equation helps you graph the line. So if we use the slope, if we use the equation rise over run, well, we need to know what the rise and the run is for the slope. And for this line, we know that the slope is 3. So how is that a rise and a run? Well, how do we write 3 as a fraction? We write 3 as a fraction by putting it as 3 over 1. So we know that we have a run of 1 and a rise of 3. And both of these are positive. So we know that this is a point on the line. That's our y-intercept. And from there, our line has a run of 1, which means we need to go 1 space to the right. It then has a rise of 3, which means we have to go up 3 spaces. You'll also notice that my scale here is counting in ones. So those squares there represent the value of 1. So that does show a run of 1 and a rise of 3. So the next point on my graph is here. And I can continue from that point. Again, I can show a run of 1 and a rise of 3. And we have another point on the graph. And if I keep going, let's do one more, a run of 1 and a rise of 3. And we've got our 4th point on the graph. So now that's enough to see that this is making a line when we join these dots together. And it's the same line that we graphed when we used the ordered pairs. We did come up with some ordered pairs originally, but here we didn't have to use the ordered pairs. We used the equation and we looked first at, well, what's the y-intercept? And from that y-intercept, what is our run and our rise? And from that y-intercept, we can move along our run and our rise to get to the next point, and so on. So here's the second equation that we looked at when we were graphing ordered pairs. And again, this time we're going to graph this equation. This is a linear equation. We're going to graph it just looking at the equation. And we're going to start with the y-intercept, because in order to graph this line, we need to know what coordinates are on the line. And right away, we know one of the coordinates is 0, -3. That's our y-intercept. So that's our point there. So we need more than one point in order to be able to graph a line. So the next thing we're going to look at is our slope. And again, we're going to recall that our original equation for slope was rise over run. And the nice thing about this slope, here it's actually helpful that it's already written as a fraction, because we can look at that and we can know what our run is and what our rise is. So in this case now we have a run of 5, and it's a positive 5, so that means we go to the right 5 places, and our rise is 2, so we have to go up 2. And so this point here, that's the next point on our line. And I can continue. If I go 5 over and 2 up, that's my run of 5 and my rise of 2. There's my next coordinate. And we already graphed this line, so it should match up with your original graph when we graphed the ordered pairs. It's the same graph, but this time we used the y-intercept first and plotted that, and then we used the slope to use the rise and the run, or the run and the rise, and come up with the other ordered pairs, the other coordinates on this line. And now 3 or 4 is enough to see that it is making the shape of a line. And once you see that, you can join them together, and it does go on forever in both directions, as long as there are no limitations on what x can be. Let's look at one last example here, where again we're going to graph this line using the y-intercept and then the slope. So if we start with the y-intercept, it's positive 2. So that's our coordinate 0, positive 2, which is there. And we're going to use our rise and our run here. So our equation for slope was rise over run. That was our original equation. And once again here, this slope is written as a fraction, which is actually helpful when we want to understand what the rise and the run are. So we can see we have a run of positive 4. But in this case, we've got a rise of negative 3. Well, a run of positive 4 means we go over to the right 4 places. So we're going to start at that y-intercept, and we're going to go 4 places to the right, which will get us here. But now our rise is a negative 3, which means we can't go up 3. So if we're not going to go up 3, our rise has to go down. So we're going to go down 3, and our next point will be there. So there's our run of 4 and our rise of negative 3. And we could keep going, but it will make that line, which will now join together and get to go on forever in both directions. And now we've graphed that line, y equals negative 3 over 4x plus 2, by using the y-intercept and the rise and the run in the slope. So to finish off our lesson on graphing the line using ordered pairs from the equation, and using the slope and y-intercept from the equation, for each of these equations here, I want you to state 4 coordinates for each line. If you have graph paper and you want to graph them, you can go ahead. But by now you should understand how to graph ordered pairs. So just stating 4 coordinates for each line, and use either method, the calculating the ordered pairs as we did with the first half of the lesson, or using the slope and the y-intercept to come up with the ordered pairs. With questions number 3 and 4, you're going to have to write them in y equals mx plus b first if you want to use either one of those methods. I'm going to tell you with question number 4, there are going to be some fractions involved, so you're going to have to use some skills of adding and subtracting fractions there in order to come up with some ordered pairs. If you're able to do that, congratulations, you have a firm understanding of how to graph the equation of a line using ordered pairs and using the slope and the y-intercept.